Alright, welcome to one of our last videos in the series where we'll talk a little bit more about financial maths. There's a question on the screen there that you can have a go at in your own time. Today we're going to talk about growth and decay. That's what we want to deal with today. So that's where we're up to in our plan, right in the middle there. Growth and decay, we've got an exam coming up shortly. We'll be looking at exercise 1.6 with, we can just concentrate on those questions in that middle box if you like. All right, compound interest formula is one that we've visited a couple of times. It's been used to, we've modified it to apply to depreciation questions. We've applied it to appreciation calculations where things sort of go exponentially up or down. But it can also be used to model growth, such as population growth, bacteria growth, anything like that. And you can see it's the same formula just there, very similar to what we had before. We just need to know that the terminology is slightly different. Our A is our final number. Now originally it was principal plus interest. So in this case, it's the accumulated total of however much this thing's grown. If we're talking about a human population or the number of bacteria, it's how many bacteria we end up with at the end of the time periods we're looking at. P is our initial number, a little bit like what the principal was with compound interest. R's like our interest rate, it's the growth rate. Usually it's expressed as some sort of percentage, something along those lines. Similar to compound interest, it's the growth rate in a time period. So if we're looking at human growth, population growth over a period of years, it would be the percentage increase each year or per annum. And N again represents our time periods. So if we're looking at growth over 7 years, each year for 7 years, then N is the number of years. All right, let's have a look at an example. Population of a district starts at 3,200 people. What will be the population in 7 years' time? And we're going to look at two different growth rates. We've got 4% per year or 1.2% per month. Let's have a look at it. So like always, write out what we know. We know that the population started at 32,000. We know that the growth rate is 4% per year, 4 over 100, which is 0.04, and we know that it's going to be for 7 years. Once we know that, it's pretty straightforward. A is what we're trying to find out because it asked us, what will the total population be in 7 years' time? That's my A. Okay, so then once we've written down what we know, write down the formula, substitute in the numbers. P is 32,000, so he goes in there. R is my growth rate, 0.04, and N is the number of years, 7. That's how we get them. Plug it into your calculator. Once again, do it in a certain way. You might want to do the 4 divided by 100 first, plus 1, then do to the power of 7, and then multiply by your 32,000. That's one way of doing it. What do we end up with? 42,110 is what our population will be. Okay, the next one is 1.2% per month. So once again, we write down what we know. We know the starting population. We know the growth rate is 1.2% per month. 1.2 divided by 100, and that's per month. So we need the time periods in months. 7 years times 12 months is 84 years. If this is per month, this is per month. If I leave my growth rate per year, then I need to make sure this is per year. Okay, you make sure they're in the same units. Got our unknowns, write the formula down, substitute the numbers in, and what have we got? 87,159 is what the population will be. Much, much higher. Okay. Hello. Okay, so the opposite of growth is decay. So we can once again modify the formula to do decay. And it's basically the same thing, except just like depreciation, that plus becomes a minus. So things decay over time, such as the examples there, we've got radioactive decay, a sporting knockout tournament, teams play each other and knock each other out, and the decay in that case is how many teams are left. And if you think of like the footy finals or something like that, there is only one team left at the end and they are the winners, the premiers, whatever. So that's our decay, things decreasing in number over time. It might be something like how the spread of, say, a vaccine or something can reduce the amount of disease or something that's passed around, anything like that. It could be how many times a particular joke or something is shared online. It may be sort of growth at the start and then decay at the end because the amount that it gets shared just drops off considerably as everyone's seen the joke. Let's have a look at an example. The initial number of subscribers to a magazine was 12,469. How many subscribers will there be after 9 months if it decreases by 1% a month or 0.25% a day? Okay, so we need to make sure we get our units right. This is sort of the situation similar to what newspapers are going through these days. Once upon a time, a newspaper was the main way everybody got their information and news and so on. Nowadays, with things like the internet, it's not so common. So subscribing to newspapers has really decayed over time. So what do we do? Once again, write down what we know. I know that my starting value was 12,469. That's kind of like my principal, which was the amount of money I started with in interest calculations. In this case, it's the number of people subscribed at the start. Write down my growth rate or decay rate, 1% per month. Once again, 1 over 100 is how we write the percentage as a decimal, and that is the same as 0.01. And it is per month. My time period's given to me in months. They're both the same, so I'm happy. Once I've got everything there, put your formula down. Substituting your numbers is the next easy step. Instead of the P, you write the number. Instead of the R, you write the number, and so on, and calculate an answer. So after 9 months, instead of almost 12,500, you should have almost 11,400. Okay, same question in the next part, but it's a different calculation. The difference is the 0.25% per day is the decay rate. So that would be 0.25 divided by 100, which is written there. 9 months, it says assume 30 days per month. 9 months times 30 days is 270 days, and it's decaying that much per day. Put your formula down, substitute in your numbers, plug it into your calculator. You should have, what's that, 6,343. You'd typically round that number up, okay, as we've done here. 6,344 would be the whole number of subscribers, because obviously you can't have 0.3 of a subscription to a magazine. They're only whole numbers. It's what we call discrete data, just whole numbers. All right, we've covered a lot of things today, but it's basically just a modification of compound interest, which we've looked at a few times already. Make sure you have a go at the work you've got to do. Thanks for coming.